Couchbase. I'll give a little background of my history. I've been a developer for many, many years, uh, and I really dealt a lot with startup culture and startup life of getting products to market as fast as possible and agile development. I did a lot of .NET and moved over to Ruby and Rails. And I'm still kind of in that Ruby Rails joy and expanding into Go, actually, of all things, the new language Go. So I joined Couchbase not too long ago, and I help startups with scalability choices and technology choices and modeling with NoSQL and Couchbase. So my information's on here. You can feel free to contact me anytime, and I love answering questions and helping people out. So this session is about developing with Couchbase One. It's oriented towards getting you started and familiar with the concepts in Couchbase, um, getting set up with the development SDKs and environments, and then we'll go talk about some modeling concepts, differences between RDBMS and NoSQL and Couchbase operations. So first things first is, in order to have fun with Couchbase, you've got to set up your development environment, get a Couchbase server installed, and get an SDK going. So uh, right now we are in Couchbase Server 2.0 beta, and something we're very excited about. We've added a number of new features and improvements over our 1.8 release. We are very close to a GA release. You can go to couchbase.com/couchbase-server/beta to download that, or go directly to couchbase.com/download and select the 2.0 recent builds to get the most recent 2.0 build. Of course, we support Ubuntu, Red Hat, Mac OS X, and Windows. Um, when you download and follow the instructions for the particular OS, which is clearly on the downloads page by each OS download, you open it up in your local host, and you have a nice wizard to finish your and complete your setup. And that would be the port 8091 on localhost. That's our port for our admin console. So this should take you no more than a couple minutes to get Couchbase server up. And then we have SDKs for just about every major language. Java, .NET, Ruby, Node.js, C, Python, and PHP. A lot of these libraries, like the Node one, is relatively new and in heavy development. Some libraries are actually being revisited and redeveloped to be even faster. Um, if you go to couchbase.com/develop, you can see the list. You're going to want to look for the ones that are compatible with 2.0 if you're using the 2.0 beta product, which you can see on the web page. There's two columns, one for 1.8.x and the others in the second column for 2.0. We also have some community SDKs for Go and Clojure, JRuby, and the Play framework that are in development and or semi-mature. If you're interested in those languages and technologies, there's stuff you can play with. Our SDKs are centered around C and Java. So we have the .NET, Ruby, PHP, Node.js, and Python SDKs are actually wrappers around our communication C library, which is our binary communication with Couchbase Server. So they run really, really fast, and they have libcouchbase as a commonality. And then within the JVM, we have the Java SDK, which Clojure and Scala and JRuby and Play are actually wrappers around the Java SDKs. So we basically have two centers for that are a core for our SDKs, and the language-specific wrappers and DSLs and what you would expect around those libraries. We also have Go, which has its own library, and one of our co-founders is a Go fanatic, and he's our chief architect and has written Go support as well. which is really fun to use. So we'll get into the Smart Client SDKs. So the way Couchbase Server works is we don't have a central point of contact. We don't have a bottleneck of going through like a single point of contact. So our Couchbase clients are called smart clients. So when they make a connection to your Couchbase server, they receive a topology map of the cluster. From then on, they actually connect directly with the node in the cluster that is responsible for that data that they hold. So based on the key, and you're going to understand this a little bit more later, based on the key, a specific node on the cluster is responsible for that key and value, and so the client connects directly, reducing latency significantly. When you add a node to the cluster, all the clients get a topology update, and then they can connect directly to that node as well. So it maintains, the smart clients maintain a topology map of your Couchbase cluster. So Couchbase is a document database. So let's talk about what a document database is. And most everyone is familiar with relational databases. So we're going to talk about it from the point of view of how it is different than relational databases. Martin Fowler is a great writer, and he wrote a book called NoSQL Distilled, and he talked about some interesting concepts in there that I think are a great way of understanding where NoSQL came from. So an aggregate view of data, if you look on the left, you see a view that might be on a web page or in an app, like a local app, where you have a view of data. Now this data in a relational system comes from multiple tables in your system because you break it out and normalize your data in relational systems. But your view is an aggregate view. It's aggregating the data from all these different tables into a single view. This is called the aggregate view of data. In NoSQL, you are, instead of breaking things out into tables through normalization, you're storing documents in denormalized forms. That means that you're actually storing aggregate data together in JSON documents. So while you would be aggregating or denormalizing with queries and joins, where clauses, and order by clauses, you are actually that process is actually called denormalization or aggregation, and that is one of the big differences between document databases and relational databases. And there's a number of reasons for why this is advantageous. So here's an example of the same view, aggregate view, but on the right side you see a JSON document that represents that view, and as you can see, all the data for that view is within that document. Right, you've got line items and the payment information, the customer information, and this is just an example. So there are many different ways of breaking this up, and you're going to understand that a little bit more as we go through this webinar. So one of the advantages is that of this type of architecture is that you can distribute your data very easily. So Couchbase excels at being able to distribute data across a cluster, and you can scale horizontally. It is because of these documents, because there's no relational tables required, it can actually distribute the data very easily. You can have more flexibility in terms of the structure of the documents because Couchbase is schemaless or schema flexible. It doesn't have enforced schema from the database side. And it reduces the latency because, it's particularly in Couchbase as a NoSQL, you can go directly to the node that has that data and get it without going through a bottleneck of a single node, routing requests. So this makes Couchbase extremely fast. And this is for web scale applications. This is one of the reasons NoSQL emerged in the mid-2000s as audiences grew, more devices were being used for applications. We had increased traffic to websites, and NoSQL became a solution for a lot of the problems that relational databases had with scalability. And we're going to go through this a little bit more. Basically, we're repeating what I've said so we understand it in a different way. So In a relational model, it's very structured. You have a fixed schema. Changing the schema requires you to take down the database, make alterations like alter table or create table or change indexes, and then bring it back up. In a document data model, it's much more flexible. You can actually change the data structure on the fly dynamically. Um, so here's a typical, normalization. I have users, and then I have, addresses that they correspond to, what city and zip code they're in. Um, we're using, a foreign key here to join the tables in this query at the bottom we're all familiar with. In a document structure, as I said, it's an aggregate. So instead of having this foreign key in this situation, what we're typically doing is creating an aggregate view of that data. So we have a single document that represents the aggregate of those two, right? So the JSON document structure, the way it's stored in Couchbase, has two different parts. For the most part, you only deal with the document, the document value at the bottom there. But inside Couchbase, we also have metadata about the document. One is the key or the ID for that document, and also we have the expiration time and the type of data it is. All the keys within Couchbase cluster are kept in RAM. This has a very important purpose. One is to know whether it exists or not in an extremely fast manner, and this is very useful to know. It increases performance tremendously, and it also is the way that we shard data across the cluster. We use the key and hash it into our distribution architecture. And we're not going to go through the architecture in this webinar in order to make time for talking more about modeling. But there are other webinars that we've already done that talk about that in the last about a month or so. We've had a lot of webinars talking about the architecture. If you want to learn more about that, please go and check out those webinars that we've already done to get a deeper view on how the architecture works. So the document value is also stored in RAM whenever, based on your RAM allocation, it'll keep the most recently used items in memory. So it is extremely fast, and you get RAM level performance for your values of your documents as well. So document keys are an interesting part of Couchbase, and it's where a lot of developers are, learning a new concept that's very different from your SQL structure, and that you have to decide what your keys are going to be. So keys have to be unique within a database, which we call a bucket in Couchbase, and the bucket acts as like a namespace for keys. So they're generally there are two categories for keys. One is like human readable keys, and the others are random generated, like integer-based keys or time-based keys or UUIDs. Human readable keys tend toward the unique descriptors of the data. So for users, it could be an email address or a username or a phone number or their social media ID. For other things like products, it could be your SKUs or anything else that makes that product unique used as a key. So here is a simple example of a user object being serialized to JSON. It's being stored in Couchbase and then retrieved as JSON and deserialized back into the user object. So as you can see, we have a key, which is my email address there, and my data serialized and deserialized back into objects. So Couchbase can store other things too. I mean, we focus on documents for a lot of reasons because that tends to be how you store most of your data. But we can store binary blobs and strings, and we have a special structure called atomic counters, which is very useful. Atomic counters are positive integer values. And they have atomic operations. That means all operations on atomic counters are executed by Couchbase Server in order. So you're guaranteed to be executed in order, which is very useful. And this happens a lot. most people want to know how big a document can be, and our limitation is 20 megabytes. So indexing and querying your data is, we can't cover it in this webinar, but we are going to be covering it in upcoming webinars, and we've already gone into a lot of detail in previous webinars. In the titles you can see at the bottom: indexing and querying, incremental MapReduce for real-time analytics, and the full text search integration with Elasticsearch. We're actually previous webinars that we just did. I recommend you check them out, and it's very powerful and very interesting stuff that's new in 2.0. And so you can actually index and search through and query your views in your Couchbase data. And learning about it is pretty much the next step after you understand sort of the basic concepts from this webinar. So Couchbase operations. We have getting a document via the key. We have setting a document and via a key and the document value. The set command overwrites it if it exists. And then we have two other commands which are useful. One is add. Their variants on the set command. Add only stores a document if it doesn't exist. It returns an error or an exception if it exists already. And replace only stores it if it exists already and returns an error if it doesn't exist. Then we have a compare and swap operation, which will only change the document if it hasn't changed while executing this operation. And that's one way of dealing with highly changing data, like a particular document or key that is changing rapidly, and you need to ensure that one change happens at a time. You can use the compare and swap operation. The atomic counter operations have increment and decrement, and based on the library you're using, they're slightly different syntax for how what you want to increment by, or whether you want to initialize if it doesn't exist. There's a lot of convenience parameters for all these functions. You have to refer to the documentation for each individual library, but they're all fairly similar. So one of the things that challenge people coming from SQL world is really how you use Couchbase in terms of the operations. In SQL, we kind of have a feeling and already know that our operations are expensive, meaning it takes time to produce the results, especially if we have very complex joins or large indexes. As the data grows, it gets a little bit slower, so we avoid hitting the database as much as possible. We try and use caching and optimization as much as possible. But in Couchbase, things are a little bit different. The get and set operations are so fast, they're trivial. And I think that when you're coming from the SQL world, this isn't actually an adjustment, a mental adjustment to make. That having multiple gets in a row and traversing through relationships that might be in documents is not uncommon, and they're extremely fast. There's no computation required on Couchbase's side to create joins across large supersets of tables. Therefore, these operations are very fast, very fast. And I think that within the first few weeks, I think people tend to think in terms of how SQL was and not in terms of how Couchbase was, and adjust slowly and realize that they can actually have many operations to achieve a result versus having a single giant one that you would use in SQL. Now let's go through a quick example. So here on the right side, we've got we're going to do things in Ruby, because actually Ruby makes it very easy for slides because of the syntax is very light and easy to read. But you can translate this. It's very simple, so you can translate this easily into other languages. In this case, I have a class. It's a user. The attribute accessor, aril, is just a shortcut method for making getters and setters for those instance variables. My initialize method is basically saying if I have a getter and setter for this value based on the hash key, set the value. And then I have a save function down there that actually takes my instance variables, converts them to JSON, and uses the email address as the key for the document. So on the left, you can see using it. I'm creating a new user there. I'm passing in a hash of my information, and then I'm saving it. So very simple. It's saving a document with those JSON values. What's great about Couchbase is actually the flexibility of development and agile development. Without having to do migrations, you can actually develop applications really, really fast. So in this case, what I'm doing is adding a lookup method. So I want to be able to look up that user by email address. So I'm creating a class method called find by email. And what I'm doing is retrieving a document based on that email address. And then if the document exists, I'm going to create a user and return it, a user object and return it. Otherwise, I'm going to return nil. So on the left side, you can see that after I've created a user, I'm finding the user by that email address, and then if it exists, I'm outputting user found, and then if it doesn't, I say the user is not registered. This is a simple example, but it illustrates some of the principles of how you work with Couchbase. And now later I realize I want to save their Facebook ID and their access token, so I add a few more instance variables, and then on the left side I add that data and save it again. And that's how easy it actually is. In my case, because I'm just saving instance variables to JSON, I actually don't have to change anything. I don't have to write a database migration or add any columns manually, to my SQL server. Whether in this case, I'm just actually adding fields to my document. Okay, I'm gonna check and see if anybody has any questions. I actually would prefer to cover all questions at the end because I do want to get through a lot of content here. I think it'd be more beneficial if I get through more content. So actually what I'll do is I'll save questions for the end. And if there are any questions that are really too involved to answer in the webinar, what I'll do is we can follow up after the webinar via email. So often you actually have a variation between whether you represent a one-to-one relationship between objects and documents, or you have more than one document for an object. And let's cover a simple example of this, and this happens quite often. So in the case of my blog, I have a user profile, and then I have a blog post that's an object that has the content of the blog. And then when it comes to the blog comments, I have two options to store it. I can keep it with the blog document. It could be if I have a less popular blog, I only have a few comments. That may make sense, actually. It's simpler in that case. Or if I actually have a very popular blog, it might be more beneficial to not have my blog document grow, really large and have thousands of comments in the blog document, but instead separate it out. So here's the example of the first one. Here I have a single document that represents the blog post, and I have an array of comments down below, as a JSON key, that has all the comments. Right now there's only 2 comments. So this is the more simple model. And then in the multiple document model, what I have instead is in my blog post object, instead of having an array of comments, I have an integer that represents the number of comments, and I use that number of comments to basically key the comment object. So here are the same 2 comments, but the key is based on the ID of the blog post plus the comment number, and then I have the body of the comment as well. And so I have 2 of these because I have 2 comments. So in this case, I've taken the functionality of the blog post aggregate, and I've split it up into multiple documents, right? And another way of doing this is also to split out into multiple documents, but in this case, what I do is I have an atomic counter for the number of comments there, and I still use that counter to ID on the comment objects. So there are different model structures. The first one is the simple one, where you have a one-to-one mapping of each object has its own document and stored in Couchbase. Then you have a little bit more complex models where you have multiple documents representing an object for different parts, maybe different collections or hashes or counters that keep track of stats or things like that. It might be advantageous to split it up into multiple documents and have the object interact with those documents on a method level. And here's a more complex model, where I have multiple documents and relationships between items, and it's just useful to see that models can get complex, and that's commonplace. I didn't want to just show you only a simple model. In this case, this is a pretty common model. You've got users, you've got shopping carts. Those shopping carts have cart items. Those cart items refer to products. Orders also refer to products. And in each of these might have multiple or single JSON documents representing them. So this is useful to understand that you can have relationships in a NoSQL document database. What you're not doing is joining them in order to create the aggregate view. What you have are each of these are aggregate views of your model. And rather than having an orders table with a foreign key, you actually have an order that has a relationship in terms of an ID to a user. So you don't have to create a join, but let's just say you are listing all your orders out and you also want to pull the user information. What you would do is actually get all the IDs from the orders and do a multi-get on all the users. And in SQL, you would think of that as a very expensive operation because you're thinking of all these individual select queries. But in Couchbase, this is actually very fast, and you wouldn't need to avoid it. You would have very low latency in these situations, and you can collect those. You can collect those through multi-get if you wanted to sort of create a join on your own in your application layer. There are other ways of doing this. There are many ways of doing things, and this is really just the intro to Couchbase and learning how to think in terms of aggregates and documents. So here are a few tips for deciding whether I should have a single or multiple documents to represent my my objects. If an object is really simple, a single document is generally best. There's no need to make it overly complicated. I think that in general, if you can get away with a single document and it makes sense, that's the best way to go. Less is more in that situation. There's no disadvantage to multiple documents. You can split up everything, except maybe it becomes a little too hard to keep track of in your own model. So you want to understand your model. So you want to keep things as simple as possible. However, if you have a very complex, huge document, and you have sort of a document bloating, it might actually be better to split it up into multiple documents that make sense for you, so that it's easier in terms of understanding your application code. Your model ends up being a little bit simpler, and it's probably easier to test as well, right? Instead of having a giant documents, you have smaller chunks of documents that represent collections or different aspects of data. That's another way of thinking of how to go decide between single and multiple documents. If you have large or limitless lists, like if you have a blog, for instance, that have thousands of comments, or hundreds of comments, and you don't really want to bloat your main blog document, this is a great opportunity to use multiple documents or using an atomic counter scheme as a pattern. Atomic counters are great for keeping track of numerical information. I used it all the time for aggregating stats, on usage of my sites. I mean, not as a replacement for Google Analytics, but in terms of within my model, I want to keep track of certain things numerically. Atomic counters are great, and the operations are extremely fast. And actually, atomic counters can be used to create key patterns. So if you have like the number of users in your system, and every time you add a new user, you increase the counter, you can use that value to actually key the user ID. So you can have user : 1 for the first user, or user : 100 for the 100th user. There's a lot of patterns you can use, and actually we have some resources for learning about those patterns. out on the internet, which at the end of this slide I have a bunch of links that you can check out to learn more about key value patterns and other things. So in summary, what we've talked about is that Couchbase is a document database. It has easy scalability, consistent high performance, always on, 24/7, 365. Couchbase operations are super fast. You don't have to avoid multiple gets. Yeah, you don't have to avoid multiple sets. You can traverse your documents with these gets and sets. You can, use these operations liberally. Um, as you, of course, whenever you refactor, you always make things more efficient, but you shouldn't feel like at the very beginning you should avoid using multiple gets. It's actually very convenient. Modeling can be simple one-to-one mappings. They can involve multiple documents, and you can have relationships within your JSON documents. You're not creating joins; you're just creating relationships, through IDs and lists, etc. All right, so here is, I didn't actually go the whole time. I wanted to leave, I guess I moved pretty fast, so I do have time for questions, which is great. And on this page, we have a bunch of resources. IRC is a great place to get help. A lot of our core developer team hangs out on there. The SDK team hangs out on there. Uh, we have our forums, which is another great place to ask questions. To our docs, that URL in particular has a list of all the docs available, including SDK docs. You can contact me directly on Twitter. You can contact me by email. And I run a few sites that are in development. One is couchbasemodels.com, where I talk about design patterns. Another is particular to Rails, but it does have some useful information in general, couchbaseonrails.com. And one of my evangelist compadres is going to be making the Couchbase on Node specific to that because he has a strong interest in Node.js. So with that, thanks for watching. I will now kind of check out questions. And, oh, we have a lot of questions. So good, I have some time here to get into it. So, one of the questions was related to the difference between foreign key relationships in SQL or relational systems versus having a referential ID in a Couchbase document. The question is, in SQL, you only have to change a foreign key in a single row. What would you have to do in Couchbase if you're referring to an ID? That's a good question. There are actually a number of different ways of dealing with that. Yes, you would, if you have refer to, let's just say, you have a SKU and you have all these orders that refer to that SKU, and you want to change that SKU. I don't think that that's necessarily the best solution, but what you would have to do is iterate through all the orders and alter the SKU to match your change in SKU. Of course, there's much better solutions that you know in the case of that situation, I would rather create a new SKU for the product and then have a JSON key in the original document that refers to the new SKU. And that's actually an easier way of dealing with it, so you don't actually have to iterate and change everything. I mean, that's a complex question. It really depends on how you design your model. You can create these situations or avoid these situations pretty easily. Uh, So one of the comments was that in the case of keeping aggregates, you would be storing a lot more data in this scenario. So here's the slide that he was talking about, and I think that one of the advantages of using NoSQL is scalability and performance. If you were doing SQL sharding, you would also be duplicating a lot of data. Same with the replication scenario in SQL Server and SQL scenarios. So I think that those considerations, disk space is cheap, but performance is not. So I think one of the primary reasons people choose NoSQL is because of the speed and the scalability, being able to scale across horizontally. We have numerous examples of situations. One, for instance, like Orbitz went from 400 Oracle servers to 70 Couchbase servers. That was an incredible savings. But not only that, their database availability went from 70% to 100%. So, I mean, there are a lot of differences between NoSQL and relational systems, but I think that those are actually uh, worthwhile trade-offs, and in most situations that you know require scale. So, uh, so someone was asking whether you can use numerical IDs and friendly URLs instead of GUIDs. And of course, actually, you can decide what your key structure is. You basically have 256 bytes to work with, and although it's probably better to keep it shorter than that, uh, uh, you can use whatever you want for your keying. So the key design is up to the developer, up to you. The size of the atomic counter integer, and actually, it's huge. I think it's actually bigger than a big int. I don't remember the exact number of bytes, but I know it's at least in 64, if not bigger. Um, so does Couchbase support atomic transactions? We do support single document transactions. What that means is that I can lock and change a particular document without and lock and change a particular document, but I can't do a multi-document transaction, which is more typical in relational scenarios. So we have single document transactions, and atomic counters are atomic within a cluster. There are some considerations when you use cross data center replication. You have multiple clusters in multiple locations. That's an important thing to learn if you're moving to that situation. Generally, developers who are starting to use Couchbase and NoSQL don't typically have multiple data centers from the outset. But if you do, it's important to learn a little bit more about that and how key value patterns should be altered slightly to deal with multiple data centers. What I mean by multiple data centers, just to be clear, is multiple Couchbase clusters at multiple data centers. It could be actually multiple clusters in the same data center, but when you have two different clusters and they're communicating through cross data center replication, there are some things to understand about consistency between those two clusters. Another question is about indexing, but I would recommend you go check out my webinar on uh, incremental MapReduce for real-time analytics. It's a great summary of views, and we also have another one for indexing and querying that happened before that that's also excellent. If you understand sort of all the concepts in here and you're ready to understand indexing, I recommend checking out those webinars. Those are great. This question was about whether it's useful to have multiple documents or a single document. And as I said, it does depend a little bit on your model and what you're doing and how much content. But generally speaking, if you're going to have a lot of content in a single document, it's probably advisable to have multiple documents or a different scheme to deal with that volume. You don't want your documents to go past 20 megabytes, and you don't generally want to bloat your documents because it makes it actually harder on your development and your application code development and testing. If you want to do unit testing and use RSpec or other testing frameworks, it's easier to think of things in smaller chunks. So if you have very large document testing, I think it's a little bit more complicated. Do I recommend Couchbase for money transactions? Uh, yes, actually, a lot of people do use it for. We have failover and failsafe mechanisms in Couchbase Cluster, and a lot of people do use it actually for financial transactions. If you need transaction auditing, you can look at running Datomic on Couchbase. It's a level 3 ACID database by the creator of Clojure, Rich Hickes. If you're looking for very serious auditing and transactions for financial services, that's one place you can look if you need that kind of functionality. Uh, But in terms of the performance and characteristics of Couchbase, as I said, we have document level transactions, and we have observe commands. It's a little bit more advanced. We didn't cover it in this developing with Couchbase 1, but we have observe commands to ensure that anything that's written has been persisted to disk. Uh, uh, and so we have special commands to deal with those kinds of situations. Those commands take a little longer than the get and set commands because you're ensuring everything is made it to disk before returning. It's basically observing and making sure it reports back with a callback that it has actually been persisted to disk. So we are a consistent, eventually persisted database. So that's important to understand. We're not eventually consistent. We are a consistent database that is eventually persisted, and we have a disk write queue that deals with persistence, and we have replication within our cluster for failsafe. Uh, so how do I find records, or how do I find keys based on criteria? That would be actually using the indexing and querying features. And as I said a few times already, since you're interested in that sort of next step of how do I actually deal with collections, how do I find keys, how do I index and query, you would be very interested in the next webinars plus the ones we've recently done. If a node goes down in a cluster, is the only way Smart Client's bucket map to be updated is by failing over the bad node? Yes, that's one of the ways, but also it will recognize errors. It's actually a Smart Client will recognize failures. It will try retrying and then report an error if it was unable to reach that node. So it's both ways. So the answer is both. If we use an email as a key, does that mean anyone who knows my email can get my data? Well, that's really sort of an IT question of whether you've exposed your Couchbase to the public. Generally speaking, most architectures actually have it behind firewall, and only the app servers have access. Uh, you don't have to use email as a key. You can also encrypt it or hash it or use some sort of algorithm if you're concerned about that. Uh, Generally speaking, that's more in the developer and your IT sort of situation than it is relative to how Couchbase is designed. Can I get only part of the document instead of getting the whole document? No, when you get a document, you get the whole thing is returned. Um, Uh, there are some interesting ways in Go that you could actually play with this if you actually store it as a string, but I can't really, it's a little bit too involved to talk about in this discussion. But yes, generally you are getting the entire document, through our SDKs. So this is actually a great question to understand buckets. And we didn't cover the architecture in detail because there really wasn't enough time, and we're focusing more on the development side. If an app starts with one bucket and can handle 10,000, 100,000 users, then traffic increase, does the bucket needs to be horizontally scaled? How does Couchbase automatically scale to this scenario? Well, in this scenario, what you're talking about is two different concepts. One is how do you add more nodes to the cluster to handle scaling? And if you're doing something on like EC2, there are or using right scale templates, you can actually automate that process through Chef or Elastic Beanstalk and all these mechanisms that Amazon offers for scaling horizontally in terms of setting up machines and having them automatically join the cluster. So that's pretty much how it works. And the amount of RAM that is allocated is across the entire cluster. So if you have 100, if you have a gigabyte per node in your cluster and you have 10 nodes, you have 10 gigabytes of RAM collectively, and data is distributed evenly across the cluster. So as you add more nodes, that redistribution is continues to be distributed evenly. So that's generally how it works. And I again recommend you check out the architecture webinars, which talk more in detail about how the architecture works. All right, this is a very long and complex question. Um, all right, one second. I think I'm going to have to answer this afterwards. Uh, this is a very long paragraph of very involved question about how do you deal with the volume of operation. And Couchbase is extremely fast. We have customers that have achieved. I mean, it really we're limited mostly by network I/O. So, if you're on Amazon, it has its own sort of network I/O cap, which you can pay to increase. Um, and generally, it seems like on a medium instance, for instance, I think you can get about 10,000 ops per second per node, and that scales linearly. So as you increase the number of nodes in your cluster, you're scaling linearly. But we had Cisco, get 1.75 million ops per second on a 5 node cluster. So that's a variable that depends a lot on hardware, um, and what your network capacity is, how they're connected together, whether you're on cloud, etc. Those are the variables in those situations. Can I attach files to documents? No, we don't have attachments to documents. That's not part of Couchbase. Um, does Couchbase client keep a persistent connection? Yes, it does. Actually, our Couchbase clients do stay connected, and generally we only need one per app server. I guess there are maybe a particular situations where you could use more than one per app server, but it's so fast. It's a binary protocol connected with Couchbase server, so you generally don't need more than one um, per app server, and it does stay connected. Yes. All right. Do I have an opinion on using Hadoop as the backend? I think Hadoop actually we pair with Hadoop really well. Uh, Hadoop is not really designed for speed. It's really more designed for volume and running large, long-running MapReduces on that data. And I think Couchbase is much more suited for real-time interactive applications. If you have offline data, let's just say you have, the genetic information of 300,000 people and you want to search for patterns, Hadoop is your answer. I mean, that's what Hadoop is excellent for. That's not a real-time interactive application. That is, doing some sort of deep analysis on a large data set, and that deep analysis can take a long time, and that's okay. Couchbase is designed for real-time, interactive applications that really need high performance. A lot of our customers have extremely high volume, or they're like in social gaming or travel, where you really need that high performance. It also allows a lot of flexibility with your modeling, so a lot of developers, including myself, just love using it because I can develop applications much faster than I can do with a relational model. The other advantage is that if you don't know the schema in advance, it's very difficult to work with a relational model. Situations like the medical industry, they can't necessarily know the entire super complex schema of every possible ailment, treatment, and diagnosis in a system. And so NoSQL has been an excellent remedy to that situation where you actually don't know the schema in advance, but you can still store the data creating a schema sort of strategy within your application code. The other thing is working with social media integration with like Facebook and Twitter and other social media, sites. You get your JSON back. You can actually, instead of replicating that in SQL in terms of creating a schema for that data, then starting to build your application, you can literally just dump that data straight into Couchbase as JSON and build your application on top of it really quickly. And that's one of the advantages of kind of, for startups and new companies trying to create applications faster, it's sort of vital in the startup world to be fast. And NoSQL and Couchbase is a distinct advantage over SQL in those scenarios for those reasons, because you can, with that flexible schema, you can, jump into your application code really quickly. With Couchbase keys and values being in RAM, how quickly does it get persisted to disk? That actually, there's one variable with that, and that's your disk I/O speed. If you're on SSDs, or if you increased your IOPS on EC2, that's going to change this answer. But every node in the cluster has a disk write queue, and it optimizes it. So if you're changing a document rapidly, it'll only push when it gets to the top of the queue. It only persist the latest change. So it's not writing every single change. So we have a lot of optimizations for that. Uh, it really depends. It can be milliseconds later, or it can be seconds later. It depends also on how much volume of data you're pushing into Couchbase, how many nodes you have. The more horizontally you scale, the higher your disk I/O throughput, because you're distributing your disk I/O over many more machines. So there's a lot of variables in this answer. So it's not like a simple, like, you know integer answer if it takes 5 milliseconds. It's a variable answer that really depends on a few things. Among the programming languages you don't mention Erlang, I think someone in the community actually was working on an Erlang SDK. I don't know the status of that. But yes, Couchbase itself is written in Erlang and C, but we haven't made an SDK for it. It's not a very common request, but I do think that there is someone who has been working on it in the community, and if you're interested in contributing, that'd be great. At this very high level, I have to. This is just a quote now. At this very high level, Couchbase sounds like a magic bullet. Why would I ever want to use SQL again? I ask myself that question all the time. When I started getting into Couchbase about a year ago, I I think I've written maybe two SQL queries since. I love using Couchbase and NoSQL. It's so much more organic to me than breaking up my data into these supersets and tables and foreign keys and normalization. It feels very artificial to me, and I actually haven't gone back since. That's not to say that SQL is not SQL databases aren't great. They are great. They're useful for a lot of things, and it's not a or type of scenario. It's a poly. It depends on what your model, what you're trying to do. It might actually be advantageous to have a polyglot persistence where you have both. It really depends, and those are very particular questions. But generally speaking, almost all the applications I work on and build now are with Couchbase by itself. Can you use Couchbase to gather user interaction data from iOS app? If so, how? Now that's a more involved question, but yes, of course you can. You can do it by creating an API interface yourself that, as an endpoint from your iOS app that you can, store your Couchbase data. I think there are services that are like New Relic for mobile. I think can do that stuff too, and but that's software as a service. So yes, of course, if you create endpoints, you can integrate with iOS or any other third-party application through your own API endpoints. Sounds like determining your key structure correctly is important. Can you talk about patterns for constructing good keys? Yes, actually, I actually am interested in making a whole nother webinar dedicated to just keying and keying examples on, let me go back to the final page here. On CouchbaseModels.com, I do write about some keying patterns. But there's a lot of creativity here, and I think that getting some of that content out is one of my objectives. And you can feel free to contact me directly if you want, if you have any questions about how you're keying, and if you need some recommendations or a second opinion. Feel free to also ask people in IRC. We all hang out there too, and we'd be more than happy to help you. Can you embed Couchbase in mobile apps? Yes, it's not Couchbase though. We do have a mobile project called TouchDB, um, and a connector called BaseCouch, and you can check those out on our GitHub account, Couchbase and Couchbase Labs, to learn more about that. Or you can follow up with me, and I can point you to the guys that are working with that. Um, So what about searching on a property or particular document information? So our MapReduce indexing actually takes JSON keys and converts them into indexes, and there's many ways of doing it, and it's a whole concept to learn. Our views are new in 2.0 and very exciting. I couldn't cover all of that in a single webinar, so please go back and check out the other webinars, and the one that's coming up in 2 weeks. Actually, we'll talk about strategies for when you would use views and MapReduce for different things. Can you index collections? Again, it's about indexing. I wish I had enough time to talk about it all. I would have had to do maybe a 2.5 hour session covering everything. Um, why is Couchbase fast compared to RDBMS? Um, Well, there are several reasons. One is that we don't have any computation required to get and set the data. We don't have to actually uh, create joins to aggregate data since it's stored as aggregates. So that's one reason it's really fast. The other reason is the binary protocol. It evolved from the Memcached to Membase server to Couchbase is extremely fast. The third reason is that we have in RAM performance. So when keys and values are in memory, you're getting RAM level performance versus pulling from disk. The fourth reason is that we can shard our data across the clusters. It's sharded based on the key, so it's evenly distributed, and the clients can communicate directly to the node that has the data. And so you're reducing latency and increasing throughput by going directly to the node responsible instead of through a central sort of router. So all these reasons are why Couchbase is faster than RDBMS. And to learn more about that, you should kind of check out the architecture webinars. They cover a little more detail than that. That was just a summary of why it works the way it works and why NoSQL was created to begin with. Where it emerged from. Wow, there's a lot of questions. I've gotten through maybe half. We're running out of time though. Um, let's see if there's anything that's not a long answer. Um, I think that most of these questions are really in comparison to other NoSQL is I don't really have time to get into all that, but what I'll do is try and address any questions that I haven't answered. Feel free to email them to me directly, and I can write out even longer answers or more involved answers if you want and have a dialogue about them so you understand further. So feel free to contact me directly if I haven't gotten to your question. I apologize. There's only so much time I can do in the webinar. Um, so feel free to reach out to me for any reason. Check out the websites that I've put together. Check out our Couchbase docs and our forums and IRC. And we're excited to see what you build and learning. We're interested in you learning more and understanding more. We're make it one of our missions to help people as much as we can. And I thank you guys for coming and watching the webinar. The slides and the video will be sent out to people afterwards, like Baxter said, I think within the next 24, 48 hours or so. And thanks for listening and coming to the webinar. And I look forward to hearing from you guys. Thank you so much.